let's look at trigonometric functions and inverse. Now, trigonometric function and inverse are taken from mathematics and being applied to the social sciences, especially in economics. So, like here we said, trigonometric functions can be defined in terms of particular ratio of sides of a right triangle. So, within the trigonometry, we have what we call the adjacent, the opposite, and the hypothesis. So, these various sides of this shape represents different cosine, sine, and tangent functions. So, if we are looking at cos A, which is cos A of this, it will just be the adjacent here divided by the hypotenuse. Yeah? So in this case, if we want to represent that, we'll just have adjacent, which is represented by this letter, divided by the hypotenuse, which is C. So that's why we have this over C. And then when you look at cos B is this one, this part of the triangle, you see that we have adjacent over hypotenuse. So the adjacent here, represented by this letter, divided by C. This is more clear in the notes. So if it's not very clear, when you look at the notes, you see what letters are represented here. But here you have A, B, and C. So if you need to look at the tangent is only saying that the opposites of this triangle must be divided by the adjacent of this triangle. And then the tangent of B, which is this, is equals to the opposite of this divided by the adjacent of this. So they are represented in different formats. So some people call it SOHCAHTOA. Some people in Nigeria will call it SOHCAHTOA. So SOHCAHTOA means sine opposite over hypotenuse. This one means cos adjacent over hypotenuse. And this one means tangent opposite over adjacent. So this is what you just use to remember this formula. So if you are looking at cos A, you just know that cos A is just adjacent over hypotenuse. If you are looking at tangent, you just know that tangent is equal to opposite over adjacent. So that's why they call it SOHCAHTOA, for easy remembrance of the formulas. So this is just a basic introduction of what this represents. And then within the trigonometric function, we have a branch of what we call the calculus, where we look at the differentiation and the integration of all of this. So here you see that in the trigonometric functions, we look at different angles, as we have seen in this right angle triangle. Look at the opposite angle, the adjacent angle, and then the hypothesis angle. So cosine graph and the rest. So, yeah, which comes down to all of this, up to a point where if you want to look at the standard units of a circle with a radius of 1, then we can go back to that triangle, right angle triangle, to see how we can get the right angle triangle of this. So when we look at the cosine, it gives us the length of the x component, and then the tangent function gives us the slope. So if you look at this, you see that it's a kind of a slope which is representing the tangent function. So we look at this here. So we have this, and then there are only two basic rules for differentiating trigonometric functions. And those rules are dx sin x is equals to cos x. This is just a formula that you should remember whenever you are looking at trigonometric functions. When it involves differentiation. Then you have what we call dx cos x is equals to minus sin x. So those are formulas that we must just know. Like if you look at this graph that we have here before, you see that sin x or cos A can be represented by the minus signs you have here. So cos x will give you the minus sin. And so for differentiating all trigonometric functions, these are the only two things that we must need to remember. So this must be at the back of your mind all the time when you're thinking of trigonometric functions using a differentiation. Because when you look at the dx of sin x, it must give you the opposite of sin x, which is cos x. And then when you look at dx cos x, it must give you the negative opposite of sin x. So those two formulas must always be at your fingertips if you want to succeed in trigonometric functions. So we have a formula here where we say sin raised to the power t plus cos raised to the power 2t must be equals to 1. So whenever we have a sine raised to the power 2 of any figure plus a cos raised to the power 2 of that same figure must always give us 1. So this is just the formulas for those two. So it means that say cos t here is equal to sin of t plus pi over 2. And then sin t here is equal to cos the bracket t minus pi over 2. So alternatively, there is an alternative formula which is similar to this. So they are all the same. So then we have various. So you can read this to understand. This does not need so much explanation. But the hypotenuse is the side opposite the right angle. In this case, side H. The hypotenuse is always the longest side of the right angle triangle. So if you go back to our right angle triangle, you see the longest side here is the hypotenuse. That's what they are saying. And then the shortest side is the adjacent of that triangle. So you see that when you are looking at the hypotenuse. Then when you look at the opposite side, you see that the opposite side of the angle is angle A in that former graph that I showed you just now. And then the adjacent side, which I said is the shortest, is representing the angles of interest between angle A and angle C. In this case, side A and B, so you see it's adjacent between B and C. So that's how to get that, and then so that's basically what we talk about. So trigonometry centers around the right angle triangle with hypotenuse, opposite, and adjacent, which represents different cos signs.